With this example, essentially what we're going to do is we're going to reverse engineer the process. I've now given you the graph of a transformed function, and I want the equation of it. We'll deal with a and b at the same time because there's actually a lot of similarities between treating this as a sine function versus a cosine function. We have four things we need to find. That would be A, B, C, and D. The easiest one to find first is D. D is the vertical shift up or down. To do that, we need to find where the middle of this function is. Normally that's right on the x-axis, but we can see in this case the x-axis is actually the bottom of the function. So the middle of the function is where half of the function goes above and half of the function goes below. If we draw this line here at 2, we can see that that's now the middle of the function. So that gives us D. And D is the same whether we treat this as a sine or a cosine. Once we know D, A is very easy to find. A is the amplitude, or how far above and below this midline that the function goes. Well, we can see that the peak goes from 2 to 4, and the trough goes from 2 to 0, so the amplitude of this function is 2. And amplitude, again, is independent of whether or not we treat this as a sine or a cosine. B is also relatively easy to find. B is the period length. Well, it's related to the period length. To find the period length, we look from either peak to peak or from trough to trough. I'm going to pick peak to peak. So we have a peak here and a peak here. We're given in radians, and I prefer degrees, so we'll change those radians into degrees. Pi over 3 is 60 degrees. And pi is 180. So what we know is that the period length is 120 degrees. Now B is not 120, but we can calculate B from this. What we know is that B equals 360 divided by the period length. 360 being the standard period length of a sine or a cosine. So then B is 360 over 120, and that's 3. And again, B is independent whether or not we're looking at this as a sine or a cosine. The only parameter that makes any difference whether we're treating this as sine or cosine is C, the horizontal shift. Because sine and cosine have different starting points, C will actually be different depending on the shift. Dealing with the cosine first, we know cosine starts at 1, or if we're dealing with a transformed graph, we can say that cosine starts at the peak of the graph. Well, we have a peak right here at 60, so then for cosine, C is 60 degrees. With sine, we don't start at the peak, we actually start at the midline, and we have a midline intersection right here, and that's at 30 degrees. So for sine, C will be 30 degrees. The only other thing we need to do is actually fill these values into the equations. We have those in the questions right here. The equations will look very similar. The only difference will be C. So we have y equals 2 sine 3 x minus 30, because it is x minus c in the equation. We've shifted right, so we'll deal with that way, plus 2. The cosine function, just as before, the only difference is going to be c, which will be 60 in this case.